Okay folks, we're going to finish off our 6-week whirlwind triangle adventure with the cosine rule and a few little exam questions. Let's go! So let's just define this straight out of the bat. I think you already know all of the definitions and nomenclature at this point. Cosine rule is as follows. If we want to find a side of a shape, then we can use this rule. A squared is b squared plus c squared minus 2bc cos a. And remember that when we're labeling our triangles, when we talk about side A and angle A, they're always opposite each other. So we could have a triangle that we labeled something like that. Sides in lowercase, angles in uppercase. I'm going to go straight into an example here. So let's do that. First thing we want to do is we want to label our sides. So let's do that. The side that we're trying to find is normally the thing you want to make A. So we'll call this A here. Let's just write it slightly further away, and obviously that means this is angle A. This means these can be side B and C in any order you like, doesn't really make a difference, we're doing the same thing with them, but they're the other two sides. So yeah, that should be fine, and let's use the formula. So A squared, which is x in this case, is equal to B squared, which is 5, C squared, minus, and if we say 2bc cos A, that's 2 times B times C times cos 60 in this case. Now if you type all that in, you'll get yourself 109 coming out. But we don't want x squared, we want x. So let's square root that, and we'll get that the length of that missing side is 10.44 centimeters. So that's it. Cosine rule, use the sides. Let's have a look at some other alternatives. So here's two other examples of the same sort of thing. I'd like you to give them a go first, and we'll come back in 3, 2, 1. Okay, let's label up our sides. So fortunately the side we're trying to find is already called A. So that's angle A, that's B, and that's C. So we're going to say that A squared is 7 squared plus 11 squared minus 2 times 7 times 11 times cos 62. And we'll get there, that will give us A squared is 97.7. So we square root that, and we'll get that the length of A is 9.88. Same thing for the second one. I would try and get in the habit of like scribbling out whatever letter they give things and say the side you're trying to find is always A, because then the formula will make more sense. If you call that B, then you have to relabel everything and the formula doesn't work anymore. So the side we're trying to find is A, that's our B, that's our C, that's our angle A. So A squared is equal to 12.5 squared this time, plus 9.5 squared, minus 2 times 9.5 times 12.5 times cos 46. So that mouthful gives us 81.5 as our answer. We'll square root that and we'll get that A is this time 9.03. Those are both centimeters, aren't they? Yeah. Yeah, hopefully you got those right, and if you can do that, you can apply the cosine rule to find sides. Let's look at angles. So this next bit is not something you'd be required to do, but you kind of got two choices. You can either learn two different versions of the same formula, or you can learn one of them and learn how to rearrange it to the other type. I'm going to show you the rearrangement. It's kind of up to you whether you want to learn this or whether you just want to remember both. So if I was trying to rearrange this, I want to make cos A the subject. I'm going to first subtract the b squared and the c squared. So we're going to end up with a squared minus b squared minus c squared on this side, and on the right hand side we've still got minus 2bc cos A. So I subtracted them. Next thing I want to do if I want to get cos A on its own is I'm going to divide, and I'm going to divide by this minus 2bc. So I'll end up with a squared minus b squared minus c squared all over minus 2bc, and that will give me cos A. So yeah, that is our rearrangement. So let's actually look at using this on a question where we have to find an angle. It says here that we're trying to find angle BAC. Remember, you're always looking for the middle letter there, so we want to find, let's label this with a theta. And let's apply our cosine rule. So we want to label stuff up first, don't we? So the angle that we're trying to find, we'll call that A. The side opposite it is obviously A as well. And then the other two sides, B and C, doesn't matter what you call them. And we'll end up with this. We'll end up with cos A is equal to, and then a fraction, 12 squared minus 15 squared minus 10.5 squared on the top, and minus 2 times 15 times 10.5 on the base. And if you work out the top and the bottom separately, which I would recommend doing, it'll mean you get a few more method marks if you mess up somewhere, you'll get that this is equal to 0.607. But we don't want to find what cos A is equal to. We want to find what the angle is. How do we get rid of cos in this situation? Well, we've done it with SOHCAHTOA, we've done it with the sine rule. We use shift cos or inverse cos. So we are going to do cos minus 1 of our 0.607. And we're going to get here 52.6 degrees. Seems straightforward enough. Let's have another couple of examples. Would very much like you to pause the video at this stage and have a go yourself, but I'm going to assume you've done that in 3, 2, 1. Okay, so always label the angle you're trying to find as A. That doesn't mean anything on the left-hand side one, but the other one we do need to relabel it. We've got side A over here, and then side B and C, doesn't matter which order we have them. So side A and B and C. And then we want to put those numbers into the formula. So cos A is equal to 8 squared minus 6 squared minus 12 squared all over minus 2 times 6 times 12. And on this other one, cos A is equal to 13 squared minus 9.1 squared minus 10.5 squared all over minus 2 times 9.1 times 10.5. Okay, so if we plug those in the calculator, then we'll get that cos A is 0.806 roughly on the first one, and we'll get just 0.126 for cos A on the second one. What do we need to do to find the angle? Of course, we need to use shift cos. So we'll do that on the first one. And we'll end up with an angle of 36.3 degrees. An excellent answer. And on the second one, we'll end up with a much bigger 82.8 degrees. Not squared, degrees. Yeah, hopefully that makes sense as well. So what could we do with this to make it awkward? Well, the problem with like the sine rule and the cosine rule is not necessarily using them, although I guess there's some finesse to it. Part of the problem is remembering them because none of these formulas are given to you in the actual exam. But the main problem is knowing which one to use and in which scenario. So I thought it was just worth going through, now we've seen all of the trig possibilities, what you'd need to use. So first off, you need to ask yourself, is my triangle right angled or not? If it is right angled, then we can use Pythagoras or we can use SOHCAHTOA. It should be pretty obvious which one you're after. It's a Pythagoras question if it's about the 3 sides of the triangle, and it's a SOHCAHTOA question if it's about 2 sides and 1 angle. I feel like those are okay to recognize. It's this sine cosine rule that I want to specialize on. We use sine and cosine rule on a triangle that isn't right angled, and we want to use the sine rule if there are 2 sides and 2 angles that are labeled. What do I mean by that? So this is a perfect example of the sine rule because we have got 2 sides labeled. We've got 41 and we've got 28, and we've got 2 angles labeled, 92 and the one we're trying to find. So I do include like the one that you don't know yet. So that's a perfect example of the sine rule. Are there any other examples of the sine rule there you can see? Yeah, there's a couple, isn't there? So this one has 2 sides and 2 angles, so this would be a sine rule, and it'd be a sine rule where we're trying to find the angle. And is there another one? Yeah, the one directly underneath it as well. 2 angles, 2 sides. We want to use the sine rule there. What about the other ones? Well, there is one right angle triangle, which is here at the bottom. We've got 4, 5 and x. We've got 3 sides labelled. So that would be, according to our little list, that would be a Pythagoras question if we wanted to solve that. And then what's left? Well, none of the other ones are right angled, so we can ignore that. This one here has 1, 2, 3 sides and an angle. So that's a cosine rule question. 1, 2, 3, and an angle cosine. 1, 2, 3, and an angle cosine. So yeah, before you start one of these trig questions, if it's not obvious what you need to do, have a count of the number of sides and angles that are labelled and try and follow that idea. So let's jump straight in with an interesting question. This is a multi-step one. There's 2 triangles involved, so we're going to have to do something with one of the triangles to find out something about the other triangle. It does kind of guide us a little bit. It gives us a step-by-step of what we need to do. There's no right angles here, so we're talking about sine rule and we're talking about cosine rule. So the first thing we need to do, according to A, is we need to find the length of AC. Now that's this length here, so we'll label that with an X. If we think about our triangles here, the bottom triangle, the ADC, would have the length 7 and the length X and the angle 68, and that's not enough to use either the sine rule or the cosine rule. Remember, you need 2 sides, 2 angles for a sine rule, 3 sides, 1 angle for a cosine. So we're going to have to use the top triangle. We've got a side, we've got a side, we've got a side, 3 sides, 1 angle. This is a cosine question. So I always find it useful, I have been doing, to draw out the specific triangle we're focusing on. We've got X, 12, and 9, and we've got an angle 93. We've identified that this is a cosine question, and it's this cosine one where we want to find the sides. So the first thing we'd need to do is probably write down the formula that we're going to use. So again, you have to go away at some point and learn this. For now, you probably just have a look back at your notes. So a squared plus b squared plus c squared, and so on. Label our sides. So always we want the angle to be the A, and the side opposite it to be the A, and the other 2 to be B and C. And then we can plug those numbers into that formula. So let's do that. We'll say x squared is equal to 12 squared plus 9 squared minus 2 times 12 times 9 times cos 93. So we'll type that all in and we'll get that x squared is equal to 248.87, square root it, and we'll get that missing side we're after is 15.78. But that's not the side, that's only part A, isn't it? We want to find B, we want to find C. So let's go through. What would we do for B? Well, for B, let's rub out what we have here. We want to find the length of CD, that's this length over here. We'll call that Y, I suppose. Now we do know that this length here is 15.78. We've worked that out. So thinking about that bottom triangle now, we have got a side, a side, a side, and an angle. This is another cosine question. So let's apply that. Again, I think it's a good idea to draw your triangle out. Label up what you know. And then go in and call things A, B, and C. Remember, always the angle that you're after, you should call that A. I'm completely ignoring the letters that are actually on the diagram because I find they don't help. A and A, and then B and C doesn't matter. We've got our formula written out already, so I'm not going to write that out again. I can go straight into using it. I can say y squared is 7 squared plus 15.78 squared. Minus 2 times 7 times 15.78 times cos, am I going to have enough room? Just about 68. Cool. So we'll type that in and we'll get ourselves that y squared is 219.34. We'll square root that and we'll get that y is 14.81, and we're just about done with B. Cool. But there's still one more question, which is C. We want to find the angle ADC. So let's rub off the diagram again. ADC is this angle here. Now what do we know? We know this is 15.78. We know this is 14.81. So if we look at that bottom triangle, what have we got? We've got 1, 2, 3 sides, and we've kind of got 2 angles as well. We've got the 68 and we've got the angle we're trying to find. So you've got a little bit of a choice here. You could use the cosine rule again, but I always find the sine rule is like nicer. So if there's an opportunity to use it, I'm going to take it. So I'm going to use the sine rule on this one. Let's draw out my triangle again, but I'm not going to copy down all the information. For the sine rule, you need 2 sides and 2 angles. So we've obviously got our 68 and our theta. We don't have any choice about the angles we're going to use, but we do have a choice about the sides. The sides always need to be opposite the angles to be useful. So we're actually going to use the 15.78 and the 14.81. Label stuff up. So angle that we're after, we'll call that A. So this is side A, angle B, side B. And then we need to remember the sine rule for an angle which is something like sine A over A is sine B over B. So remembering from last week, what we need to do is substitute stuff in, obviously. So we're going to have sine theta over 15.78 is sine 68 over 14.81. And then we multiply across. So we multiply the other side by 15.78. Then we type that in, and we get something that is almost but not quite 1. So we're going to use sine minus 1 on it, and we'll get that our missing angle there is 81.1 degrees. So there we go. Our answer to part A, our answer to part B, and our answer to part C. That last question is particularly interesting because you get to choose how you approach it. There are multiple ways and they all work. But the bare minimum of if it's cosine rule, you need 3 sides and an angle, and if it's sine rule, you need 2 sides and 2 angles are the important thing there. So I wanted to look at one last question here. This gives us an area of a triangle and tells us to work out its perimeter. It's probably worth just writing down everything that we should know at the top here. This is not right angled, so it's going to be one of these 3. So we've got half AB sine C for area. The sine rule, we've got A over sine A is B over sine B, or we can have the alternative is sine A over A equals sine B over B. And then the cosine rule, the 2 versions we've got are A squared is B squared plus C squared minus 2BC cos A, or A squared minus B squared minus C squared over minus 2BC is cos A. So yeah, just remember that you have to go into the exam with all of these 5 formula somewhere in your head. Okay, so it mentions the area of the triangle. We're clearly going to have to use the area formula, so let's start with that. We'll say that area is a half AB sine C. We want to label this up, so C is always the angle that we're after, and A and B are the 2 sides in between it. So this is going to be our A and our B, and then this is going to have to be our angle C that we find. So let's plug in what we know. We know the area is 10, so it's equal to a half times 3.2 times 8.4 times sine C. And we can obviously divide 10 by that half times 3.2 times 8.4 to just get sine C on its own. If we plug that in, we'll get 0.744, and obviously it's sine, we want the actual angle, so we're going to have to use shift sign on that, and we'll get that missing angle is 48.1 degrees. Now that is definitely not answering the question. We have not found the perimeter of the triangle. We haven't even found a missing side of the triangle yet, but it's the only thing we can do. We were given the area, we haven't got enough information, we didn't have enough information to use sine rule or cosine rule, so we had to just rearrange that and see what it gives us, and it gives us an angle, and that's okay. So if we want to find the perimeter of our triangle, we're going to need to know the length of AC. So let's call that fella X. Let's get rid of some of our labels. Now, what do we want to do here? We have got 1, 2, 3 sides, and we've got 1 angle. 3 sides, 1 angle, that's the cosine rule. If it was 2 sides, 2 angles, we'd be using sine. So to finish this off, we're going to use the cosine rule. We're going to need to label this up again, so I think the angle should always be your A, so we'll cross over that B. So this is our side A, this is our side B, this is our side C. Remember, B and C don't matter which order they go in, and it's a side of a shape that we're trying to find, so we're going to use this top right formula. So let's do that. I'm not going to write out the formula again, let's go straight into it. We want to find x squared is equal to b squared plus c squared, so 3.2 squared plus 8.4 squared minus 2bc, so 2 times 3.2 times 8.4 cos A, so times cos of 48.1. We have to be confident in our previous answer, obviously. Let's type that in, and we'll get that x squared rather is 44.9. We can square root that, and we can get overall that x is 6.7, almost exactly, centimeters. Okay, are we done? No, because we still need to find the perimeter of the triangle. So you do need that final step at the end where we add up the side lengths. So we've got our 3.2 plus our 8.4 plus our 6.7. It said give your answer to 3 significant figures. So let's see what this looks like. This is going to go to 11.6, 18.3, and yeah, that is 3 significant figures, so no rounding needed. We're in centimeters. Yeah, there we go. So if you're given a question and it's not immediately obvious what to do, count sides, count angles, and think what's the only thing I can do with the information in the question. Best of luck.